Jocelyn. What's good? I'm Trinity.
I'm Lynette, aka the editor.
Hey, I'm Giselle.
And I'm Luis. Come join us on the trip to the Natural History Museum. The Natural History Museum was once known as Los Angeles County Museum of History, Science, and Arts. Had its grand opening on November 6, 1931. It is located in Los Angeles, California at Expo Park, across from the University of South California. The museum consists of various exhibitions including Dinosaur Hall, Becoming Los Angeles, Natural Gardens, and Age of Mammals. Discovery Center, Dino Lab, Gems and Minerals, African and North American mammals, the halls of birds, and more. There are many exhibitions to explore, including online exhibitions available on their website. Let's explore the wonders of the Natural Museum together.
In the Gem and Mineral Hall, they have a collection of more than 2,000 minerals, rocks, meteorites, and gems from around the world. You'll be able to find all kinds of beautiful and unique specimens that show off its incredible variety of Earth's natural materials, exploring how geologists discover and sort different rocks and minerals. As we explored the exhibit, we were surrounded by a stunning display of gems and minerals, each with their own unique shapes, colors, and textures. Some sparkled, while others shimmered, and others had rough or earthy surfaces. But what really sets them apart from one another? Let's break it down. A mineral is a natural occurring and organic solid with a specific chemical makeup and an ordered atomic structure, which means that its atoms are arranged in a consistent repeating pattern. Minerals are the building blocks of rocks, and there are over 4,000 known types. One cool feature in the exhibit was minerals that glow under ultraviolet UV lights, a property called fluorescence. In a special dark room, they lit up in bright neon colors like green, pink, and blue. This happens when UV lights excite atoms in the minerals, causing them to release visible light. It was an awesome way to see how scientists make these minerals shine. So let's move on to rocks. Rocks are made up of one or more minerals and fall into three main types: igneous, formed from cooled magma; sedimentary, formed from compressed layers of sediments; and metamorphic, which has been changed by heat and pressures underground. So where does a gem fit in? A gem or gemstone is a mineral that has been cut and polished to be used in a jewelry or decorations. Take a look at these stunning gems in these sections. They really do stand out. But here's the thing, not all minerals can become gems. For minerals to be considered a gemstone, it must be rare, beautiful, and durable enough to be shaped and worn. That's why diamonds, sapphires, and emeralds are considered gems. However, not all gems are minerals either. Some, like amber and pearls, come from living things. Amber from tree resin and pearls from oysters, so they don't meet the criteria of being a mineral.
Trivia question time. Now here's a question to think about. Let's see if you're paying attention. Can all minerals be gemstones, or can all gemstones be minerals? The answer is no. Most minerals don't qualify as gemstones because they're too common, too soft, or not visually appealing. And while many gemstones are minerals, some are not minerals at all due to their organic origins.
Now that we have a better understanding of the differences between minerals and gems, how do we go about identifying the different types of rocks? There are three main types of rocks: igneous, sedimentary, and metamorphic. Each type forms in a different way and has unique features that help geologists tell them apart. Igneous rocks form from molten material called magma when it's underground, and lava once it erupts, cools, and hardens. If this cooling happens deep underground, the rock is called intrusive, like granite. These rocks cool slowly and have large visible crystals. If the cooling happens above ground, usually after a volcanic eruption, the rock is extrusive, like basalt. These cool quickly and have small or even invisible crystals. Some, like pumice, even trap gas bubbles and can float on water. Next, we have sedimentary rocks, which form from the buildup and compression of tiny pieces of other rocks, shells, or other organic material over a long period of time. These pieces are carried by wind, water, or ice and settle into layers. Over time, they are compacted and cemented in a process called lithification. Rocks like sandstone, shale, and conglomerate are great examples. These often contain fossils, giving us clues about ancient rivers, lakes, oceans, and even other creatures that once lived there. Lastly, there are metamorphic rocks, which form when existing rocks are changed by heat and pressure, but not melted. These changes cause minerals to realign, creating layers or banded textures. Slate, schist, and gneiss are examples of foliated, metamorphic rocks with visible layers. Others, like marble, quartzite, are not foliated and form under different conditions. These rocks can start out as igneous, sedimentary, or even other metamorphic rocks, but pressure and heat transform them completely. All of these rock types are connected through what's called the rock cycle, which shows how rocks can change from one form to another over time due to weathering, melting, cooling, or pressure. This means that rocks are in a never-ending cycle and are constantly changing. Geologists use several clues to identify rocks, like their texture, mineral content, how they were formed, color, and hardness. So while minerals and gems are beautiful on their own, they also help us understand the bigger picture, how Earth has changed and evolved over millions of years.
Rocks aren't the only things that can tell us about our Earth. Let's go way back into the time of dinosaurs. No, we can't travel back in time, but what does it let us learn about that era are the fossils found all around the world. In the dinosaur halls, there is a collection over 300 fossils, specimens, and 20 mounted skeletons on display. Through these, we learn little about these creatures, the way they walk, how they evolved, and clues about their habits. How are fossils formed, and how did they spread around the world? Dinosaur fossils formed when the soft parts of their bodies decayed, but before the whole body disappeared. If got buried in sediment like mud, sand, or slit over time, only the bones and teeth were left. These remains got trapped in layers of sediment, and as more layers built up, the pressure and the time slowly turned them into fossils. Fossils provide valuable information about past lives, forms of environment, and climate and conditions. Even though fossils have been buried for millions of years, they can still be found today. Natural forces like land being pushed up, weathering, and erosion helps bring fossils closer to the surface where scientists can discover them. Fossils are also found all over the world because a process called continental drift. Long ago, Earth continents were joined together in one giant landmass called Pangaea. Over time, this supercontinent slowly broke apart as the tectonic plates beneath the Earth's surface moved, as shown in this demonstration. This movement is explained by the theory of plate tectonics, which says Earth's crust is made out of large pieces that slowly shift over time. Because of a continental drift, fossils of the same species can be found on continents that have now been pushed way apart, showing us the landmass movement of the Earth over time, and the surface has been changing over millions of years.
Trivia question time. Do you think all the fossils in the museum are real? If you said no, you're correct. Sometimes only parts of a dinosaur's bones are found because over time, bones can break, scatter, or be lost. That means paleontologists may not always find the entire skeleton. So, to complete the fossil display, scientists use casts or replicas to fill in the missing parts and recreate what the full dinosaur might have looked like. The geologic timescale divides Earth's history into eons, eras, periods, and echoes. The most recent eon, the Phanerozoic, which began around 542 million years ago and includes three main eras: Paleozoic, Mesozoic, and Cretaceous. Dinosaurs lived during the Mesozoic, the Jurassic. Earth had one supercontinent, Pangaea, which later split, changing climates and oceans. Dinosaurs grew more diverse in the Jurassic and by the Cretaceous, they were at their peak. Famous dinosaurs like the T-Rex lived only in the late Cretaceous. The geologic timescale helps scientists understand when dinosaurs lived and how they evolved. Fossils play a key role, especially index fossils, which help date rock layers. This supports the principle of fossil succession, showing how life changed over time. Trivia question time. What do you think is older, a bug or a dinosaur? If you said bug, you're correct. Although dinosaurs lived a long time ago, insects and their relatives were around hundreds of millions of years earlier. In fact, the first animals to walk on land were probably arthropods, the scientific name for the group that includes insects.
How did Los Angeles come to be underwater? We are going to look at the exhibit LA Underwater. This exhibit shows fossils found along the coast and reveals the fossil's evolution of life. Did you know Los Angeles was underwater? Before LA became the city we know today, it happened to be underwater for over 90 million years. The LA Underwater exhibit gives us the experience of how it was like, with visual displays that show what life was like back then. It tells a story of an ancient past of nearly 40 fossils that give us clues about what the area used to look like. A lot of these fossils were found right in the middle of everyday life. For example, over 2,000 fish fossils were dug up during the construction on the Metro line. Even a whale skull was discovered by someone digging an irrigation ditch in Lincoln Heights. These local finds are helping scientists piece together what land and ocean used to be like, and how it all shaped the LA we live in now. In the exhibit, there were many fascinating discoveries and had a giant screen displaying many animals found. LA was underwater for millions of years because of the natural climate changes and movements in Earth's tectonic plates. California's coastline has always been shifting due to these forces. For about 90 million years, Los Angeles was a part of the Pacific Ocean. It wasn't until the Pleistocene epoch, when the Earth's climate cooled and massive ice sheets formed, that the sea level started to drop. These glaciers held so much water that the ocean levels dropped and parts of LA began to rise above sea level. About 19,000 years ago, the ice started melting and the sea levels rose again to where it is today. But now that the ice is speeding up because of human cause and climate change, if this continues, places like Venice and Long Beach could end up underwater again within the next 100 years.
And that wraps up our journey through the Natural History Museum. From shimmering gems and powerful geological processes to towering dinosaurs and underwater LA, we got to explore just how much of Earth's history is written in rocks, fossils, and even the ground beneath our feet. We hope you had as much fun as we did learning about the science that shapes our world. Don't forget, there's always more to discover, and you can always check out everything else the museum has to offer.